Okay, we'll give people a few seconds to join online.
I know this one.
Well, good afternoon, everyone, and welcome to the University of San Francisco's MSDS seminar series in data science. My name is Sean Butcher, and I am the Partnership Director for the Data Institute, and I'll be the MC for this presentation. The seminar series is brought to you by the University of San Francisco's Masters in Data Science program and sponsored by USS Data Institute. Today, I'm pleased to welcome Minha Hwang. Minha is a principal architect at Microsoft, and today we'll be giving a talk on data-centric causal modeling of promotion effectiveness and planning. Minha has indicated that he's happy to answer questions during the presentation. So if you have questions during the presentation, please enter them using the Q&A box in Zoom. That's either at the bottom or the top of your screen. Don't enter them using the chat button. Use the Q&A button. And if you're here in the audience, please put up your hand and I will hand you the microphone. With that said, welcome, Minha.
Thank you for the introduction, Sean. So I'm glad to have an opportunity to present my experience and research in promotion effectiveness measurement and planning. So let me please share my screen. So can you see my slide? Just want to make sure.
Yes, we can. Thank you.
Okay, so the topic that I'm going to talk about today is the causal modeling or causal machine learning in general in the use case of promotion effectiveness measurement and planning. So I assume you guys have a lot of seminar and also training and learning around the modeling. But the area that I focus today is a little bit around the modeling, but certain areas which are less emphasized in the typical learning, more on the how you actually get the data, which is required to show modeling. In usual cases, you have prepackaged data and then you focus on the modeling. But when you actually have actual use cases or in the real job, that actually the first question that will come to you will be, what data do I need and how you actually figure out this data source to start your modeling journey, right? So that's the part I'll focus quite a bit in during this talk. What kind of challenges we can see when you are assembling your data for your use cases in the focus of promotion kind of measurement and planning. Also, once you build your model, you also need to do something else beyond the modeling to really have a business impact, right? So that's the area around building some kind of end user apps or even the app, some kind of simulator or the scenario analysis tools to support actual adoption of the models, right? Because predictive modeling is pretty cool, but other than your the audience with data science, they won't be able to actually get fully utilize the insight or the modeling predictions, right? So you need to have something else beyond the modeling to actually deliver the impact. So that's the part I'm going to talk more about. And if we have time also, I will talk a little bit about going beyond the predictive modeling, so-called prescriptive analysis, right? Which is essentially optimization. So that's the three kind of area I will focus more. In terms of agenda, I will first define this business use case in terms of the business problem we are trying to solve, and then why we care about this, right? And then show you high level kind of process, starting end-to-end process, starting from the data all the way to the end user applications. And then go deeper on the data topic I just mentioned. How do you build actual data foundation? What are the key elements you need to have to allow promotion, measurement, and planning use cases? What are the typical challenges around that? And spend real time to talk about what is the difference between the causal model or the model which is attuned to measure the impact from the certain marketing activities or certain treatment, and also what kind of the application you can have once you build the causal model for promotion planning and measurement, and then talk a little bit about the after you build a model, how you can use the model to make business impact, right? And then finally wrap up with some key lessons by applying these models both in academic research and also in practice. So this is mainly from my experience as academic and also doing this for about 7 years at McKinsey company as a consulting data scientist. So those are kind of the basis for this kind of lessons I learned. So promotion effectiveness modeling and planning. So what problem are we trying to solve? So there are essentially two related problems. One of them is more like backward looking, trying to assess the past performance of the promotions, right? And the other related planning kind of problem is more forward looking predict problems, right? So as you can see from the supermarket or in many kind of retailers, promotion is pretty much everywhere, right? They spend money promotion budget to really get more incremental sales and incremental profit, right? So as an example, if you go to Safeway, there can be buy one, get one free promotion for Coca-Cola 12-ounce pack, 12 in the week of maybe November in last year, right? So there must be a reason for them to actually do this promotion. They hope to get more volume or the unit sales out of these promotions, right? So essentially there are costs you need to pay the promotion budget, and they are getting some benefit, which is the incremental volume or incremental profit. And ideally you want to have high ROI or the high incremental profit, right? So that's the ROI measurement problem. So for each individual promotion event, how can you measure the ROI of the past event, right? So that's the key kind of measurement question for the promotion effectiveness. So once you get the overall measurement, it's one thing to measure how much you made in terms of incremental profit, but it's another to actually figure out why that was the case, right? So there are related questions about the so-called promotion DNA or drivers. So what are the reasons why this was happening, right? Was it due to some seasonality or other external factors? Or is it due to that our competitor was promoting at the same time? So we actually, our promotion effectiveness wasn't great because of the co-promotion from others, right? Well, it can be due to the certain types of promotion work well for certain product or for certain locations. So the detail about the promotion design, like types of promotions, tactics, or degree of price cut, percentage discount may actually matter, right? Also, it might be just due to the cost side changes. So it did bring a lot of volume, but the cost actually went up significantly. So because of that, it ended up with actually negative profit, right? So that's possibility, right? So all those factors need to be considered, and then you can actually deep dive to do why kind of analysis. So so-called driver analysis to figure out what contributed to ROI of the promotion event, right? And with a lot of these event database together with the causal drivers, then you can also do some pattern recognition to see what kind of patterns the promotions with the best ROI or best incremental profit has, right? So those are kind of backward looking kind of promotion effective measurement problems. And once you have good understanding about the what's going on with your past promotion event, ideally you want to also use this insight and then underlying tool and modeling to plan for the future, right? So that's called as planning. So this is essentially counterfactual simulation based on some predictive model. So once you build an underlying causal machine learning demand model, in each, the promotion is one of the key drivers with other control variables. You can use this model to what if scenario analysis, right? So if you do this promotion for product X and store Y in the timing of the week G, then what's gonna happen for this sales of this product, right? So that's essentially counterfactual simulation analysis, right? And with that as a base, you can also do optimization. So instead of actually doing some scenarios for the certain kind of assumptions, you can figuring out what is the best kind of price point, what is actually best product to promote, and what is the best location to promote, right? So that's so-called promotion optimization. So that's kind of the most advanced level if you go for the planning space. And if you also want to make it dynamic, you can also come up with the calendars. So since there can be interdependency between promotion event across the time, right? So those are the business problem we are trying to solve by utilizing this promotion effective modeling. So let me give some intuition about how this works with the data, right? So I'm making very simple two examples with a single product as a graph here. So this, assuming that this is actually a unit sales you observe over the weeks, right? So you can see that without promotion in week 1, 2, 3, 4, it's pretty flat around 100. So that's basically baseline line of the sales you would expect to get, right? And then in week 5, in week 6, there was promotion. So you can see that there a bump of 140, right? But if you look carefully before and after the promotions, right, there can be a dip of 95 just before in week 5, 1 week before the promotion. Also, can be a post dip after promotion, right? This can happen because some people anticipate the promotion and then wait until promotion to happen. So you can have pre-promotion dip, or some people who were initially planning to buy week 7 was actually forward buying at week 6. So because of that, there can be post-promotion dip, right? But here, if you speculate what would have happened without promotions, right, you can actually do the yellow line here. So assuming that without the promotion, ignoring seasonality for now, then this could have been the baseline sales, right? And then you can actually compare this what if baseline sales with actual sales to quantify what was the incremental volume, right? So here in this simplified two example, so you can see that in the week 6, there are gross lift of 140 minus 100. So there are 40 additional volume based on the promotions, but that's the only effect, ignoring the loss around the post and pre-promotion dip. So you might have to adjust for this. So the loss of the 5 in the pre-promotion dip and loss of the 10 from the post-promotion dip need to be adjusted, and then you can maybe get net lift of the 25, right? So that's essentially the idea if you just have simple toy world of one product. So this actually kind of brings the fact that it's essentially a counterfactual kind of problem. So also missing data problem. So in the data, you only get to see one kind of scenario for the case, right? So for non-promotion week, you do have the promotion, non-promotion sales data, but you don't actually have the alternative world where what if you run the promotion week 3, right? That data is not available. So you have to somehow make inference about that scenario by utilizing the data from the other week or other product, right? And similarly for the promotion week, you actually get to see the sales on the promotions, but you don't actually see the sales on without the promotion. So you have to extrapolate from non-promotion week somehow to actually create a baseline, right? So that is essentially what the causal machine learning model does. It create the baseline or the alternative case kind of scenarios. And by comparing actual volume with the baseline, you can actually get to measure what would have been incremental sales. And for the non-promotion week, we can simulate what would gonna happen with the promotions, and then comparing with the non-promotion baseline give you the incremental sales, right? So this is essentially the intuition about what is going to happen if you build a proper, robust promotion effective measurement model with the causal machine learning. But there are pretty big complexity around this. Here, we are only talking about single product, even if that there can be a dependency across the timing, right? But if you now think about multiple products in unison, there can be more complications, right? Some products are more similar to each other, and the other are more distant. So you have to figure out where the volume will come from if you promote one product. Obviously, the volume will go up for the focal product, but the related product volume may go down because of the cannibalization if you are thinking about one manufacturer and their portfolios, right? So that can be a cannibalization. So basically, the increase here some of them may come from the other product in your portfolio, which is not great to have, or it may come from your competitor, right? That's called competitor growth. That in that case, that's actually great. You actually get to get most of the benefit from your competitor, not from your own portfolio, right? That would be the scenario you want to have. Or this is the another scenario. Maybe some of this increase may just come from category expansion. So non-buyers now starting to buy. So this is good news both for manufacturer and retailers. So both of them will be happier with the scenarios, right? Or it can be due to this time dependency we just described, right? So there are related questions about where this increase is coming from, right? That's another kind of question you need to answer with if you, especially when you are doing this with the multiple product in a given categories, right? So that's essentially the intuition about what we are trying to achieve with this modeling. And this is actual data about the market share in the given one specific store for the given week. So here the red line on the top is showing the market share of this product. And on the bottom, this blue line is showing the, no, actually the blue line is the market share of this product. And the red line on the top is basically price of this product. So you can see that the price at the regular price, $1, and then the sales was pretty at the normal level. But once you discount it to certain level, the sales picked up like this. And so on the bottom, it also shows that whether there is a feature or display and coupon promotion support. So there are other non-price ways of to promote, right? I will describe some details in the next page for what I meant by these three. So this actually shows that even with the actual data, the intuition I just showed kind of hold, right? So you can see that there might be some kind of baseline sales you can maybe somehow figure out, right? But with the price cut and then promotion support, there are actually pretty big increase in the sales. So with this information, you can somehow figure out the incremental volume, and from which you can actually figure out incremental sales and profit, right? Also, you can see that there might be some seasonality. Sometimes the sales goes down or up without any price cut, right? So that's another thing you need to control to make this to work. So let me also describe what I meant by this feature display coupon with actual kind of photos, right? So as if you go to supermarket or retailer, many times you will see that there are some display at the end of the aisle, right? This is called as end of aisle display or display. So obviously it's not free, so manufacturers need to pay some quite big sum of money to actually make it to happen. So, but with that, it grab more attention, so there will be a boost in sale even without the promo price cut, right? But usually this happens more with the price cut, and having this in additional price cut actually boosts sales quite a bit, right? And feature is basically what you get in your mailbox through the maybe insert into the Sunday newspaper or separate kind of promotion insert. And coupon, you guys should be familiar with the coupons. So there will be paper or digital coupon version, which allow you to get some discount, right? And also there are different kind of price card like buy one, get one free, or percentage discount, or dollar discount, or many different ways to do a price cut, right? So those are major promotion types. Also, they tend to be somewhat tailored or customized for the retailer type and also by the categories. So some prefer to do one A or the other, right? So there will be some differences across the retailers and categories and also by manufacturers. So that's what I meant by the promotion types. So why should we care about this problem? Obviously, promotion is one of the important area in marketing. A lot of money got spent on this, both from the manufacturers and retailers. As an example, the consumer packaged good companies, as you know, those who which make cereals or sodas and many items in the supermarket, as an example, they invest about 20% of the revenue in trade promotions. So it's big chunk of money gets spent on promotions. But some studies show that about 59% of those promotions actually do not make money. So some of them are actually not profitable. So figuring that out, it has been big problem for manufacturers and also retailers. And the best-in-class promotion can return 5 times more efficiency compared to average kind of players, right? And so obviously there is a big area with a lot of impact you can make. And before it was niche area with where only a few experts know how to do the data and the modeling. But now with the open source packages, which allow many of these techniques available, together with cloud and many infrastructure which allow easier data access. So this is actually more doable than in the past, right? So a lot of large consulting companies started to set up the service line of, to make this as a service. Also even making them as a software as a service kind of product, right? So there are a lot of interest in this recently because of this enablement from the data and also the open source packages. And in my experience of applying this in practice, usually I found that you don't really need complex model. Once you have proper data and simple models, assuming that you haven't done this before, the price elastic modeling to measure how the sales change with the price, that can actually bring about 1 to 2% increase in revenue if you do simple adjustment of the existing price with the modeling. Similarly, if you once you measure promotion effectiveness and then using that insight to optimize your promotion planning process, that can also bring about 1 to 2% increase in revenue, right? So it's a pretty big impact you can make by actually doing this properly. So what is needed to actually to make this to happen? So this is kind of 6-step kind of process, end-to-end process, right? So to make this to happen with the actual data and the business. So we need to start with the data foundation. So this is actually quite a critical area, also taking a lot of time in practice. So multi-week or even multi-month kind of process to make this happen. So the key is figuring out what are the key data elements you need to actually make this causal modeling to happen. So I will describe this more in detail about what are the key data areas. But essentially, the most important one is point of sales data or transaction data. If it's retailer, usually you can go with the transaction data the retailer has. Or if it's CPG manufacturer state, you can purchase the POS point of sale data aggregate at the store level or the chain level or market level from the syndicated data providers such as IRI and Nielsen. So that will be the core part of the data, but it itself is not enough. You need to actually understand your product. So you need some product hierarchy and product attribute master file to have, which has the information about product. Also, you need to have store level database, which have detail for the store. If you want to go to more customer level segmentation kind of model, sometimes you need to have customer master data too. Especially when you have the loyalty card data, you can actually have pretty good detail for the customers in terms of what they purchased in the past and stuff like that, right? Also, to assess the profit, you need the cost and margin data, financial data. And finally, since we are trying to optimize the promotions, you need detail for the promotion tactics, right? So once you kind of map out where you can get all these data, key data element, then you need to do initial data quality check and then need to do required ETL jobs to load the data onto the consolidated data lake, and then need to build the required table and then make the model ready, right? So this is essential data engineering part, but it's crucial to have this properly done. As you know, without the data, the modeling doesn't really work. So this is important foundation need to build, right? So once you load the raw data, that's the start of the data journey, then you need to do some outlier analysis and data quality check, and also some EDA to properly make it modeling ready. So that's the second data step you need to do. After you make your modeling data set ready, now you can actually build your causal demand model for each market and chain or categories, right? And there are different techniques you can utilize, but the one key thing here is that you need to control many confounding variables since we are trying to make causal inference with the observational data. Also, you need to make sure that the model is interpretable, because the application for this, the black box model doesn't work so well. So it's better to use a model which give clear interpretations in general. And also another consideration here is we need to use this for the counterfactual simulation. So some model which is doing really well in prediction make some weird counterfactual simulation results, right? That's another reason why it's better to use a model which can handle interpretation, and also you can do some check about expected direction and stuff like that, right? And finally, since this nature of the data is multivariate time series, meaning that there are multiple product, multiple store, time series over time. So you need some technique which can actually better handle this, right? So some technique like deep learning do great if you are focusing on single time series, but if you have heterogeneous kind of groups of product, multiple time series, they tend to suffer, right? So you have to cater to what kind of technique you need to use for this part, right? And once you build a model, then now the fun part begins, but it's not the finish. Building the pre-model is actually start, and you need to synthesize the model findings and then try to use this model as an engine to build your simulator. So this is actually more software engineering part. The model itself is actually not useful for the end users. So usually this is becoming an engine for your promotion simulator, and you need to build some end user app which allow them to do what if scenario analysis by putting some promotion they have planned, or go back in the time to actually assess the ROI and then do some drive analysis, right? So this is actually pretty sizable chunk to build simulator to make it actually usable for end users. And with that, you can actually use that to do some replanning by doing what if scenario analysis, right? So those are kind of 6-step kind of process to going from the data to all the way to end user usage of these tools, right? So let me go to the data part. So this is both timing consuming part and also not, it's actually the one that you can best learn by actually working on project or hand-on job. But this will require some business context. So usually you have to spend a lot of time to understand what are the available data, what are the limitations, what is the context around data, which is not recorded in the tables, right? So the core part is actually transaction data, which has the grain for this kind of modeling is usually location, product, and time. So you need to have, if you are doing store level, you need store ID and week ID, weekly level data assumption, and then some product key like UPC key. And if you want to do more refined model with customer segment, you need customer loyalty card ID as an example. But usually these 3 are enough. And then the key data field is essentially volume and the price paid or the revenue, together what kind of display account is applied. You have to enrich this with the promotion tactic causal database, which has detail about whether there are features, displays, and what kind of promotion price was applied for as a promotion. And also if there are any complex promotions, some purchase requirement. I will give some example about this later. And also what kind of promotion tactic types, right? So there are a lot of ways to give discount. So this is actually required beyond the transaction database to figure out what was actually executed as a promotions. So for this part, another caveat is that a lot of companies have planning database which have similar information, but what gets executed could have been different from what was planned. So you have to make sure that you are getting the execution data, not the planning data. And if you want to bring this to the profit level, obviously financial information will be important, especially the cost of each product by different location, together with what kind of vendor support or the promotion cost you incur for certain promotion event, right? So you need to actually marry this with the financial data. And also to get detail about the store and then product, you actually need to combine this with the store level master database and also product hierarchy and product attribute database together with consumer database, right? So usually if you start this kind of project for the company which never have done this before, obviously this kind of database not available. So you have to build this from the scratch by assembling different types of data, right? But this is quite important to make this process work. And also this will be a good foundation to have this kind of process sustainable in the future, right? So for one tip for this process, for the companies which never have done this before, it's easier to do this with the one small number of pilot categories. So if there's some company have like 20 categories under management, maybe you can quickly pick 1, 2, 3 kind of categories where you expect higher impact, and try to demonstrate the value of the approach by doing this for 1 or 3, and then you can roll this out to other categories later. That's the lesson I learned. So showing the quick win early with the pilot usually give more opportunity later, and then making the buy-in easier, right? That's something you can actually use if you want to try this for the company which never done this before. Okay, and with that, let me now focus more on what kind of data challenges I have seen in the world of the promotion modeling, right? So the first one is that there are the discount of promotions are actually quite complex in real world. So it's not enough to just have the transaction data to infer the price from the revenue and unit volume, right? So there can be more than one price point with the given product at the given one point of time. So let me take one example about how this happens, right? So let's look at the Coca-Cola soda, the classic cola 12-pack, 12 fluid ounce cans, right? Simple product, just 12 ounce can, 12 of them, right? And we are going to maybe Safeway in Burlingame. So what is price for this product? So if you ask this question, you can actually get 3 answers, right? Depending on your purchase requirement, because the reason was that there was actually price promotion with the purchase requirements. So the promotion was like must buy for 12. So essentially, you have choices of buying 4 and then pay 12. With this, you can get only pay $3 per each. So this is the promoted price, but this is only applicable if you are buying more than 4. So that's one price you can actually face. But if you are buying less than 4, you have to pay the regular price if you don't have the royalty card. So you might have to pay 4.99 as a regular price. But if you have the royalty card, they want to give some promotion, even though you are not qualifying for this. So you have fallback price of 3.49, right? With this example, depending on how much you buy, the purchase requirement, together with whether you have royalty card at hand or not, there can be different price point of applicable to you, right? So this is the real world scenario of what's happening. So it's not enough to just have transaction database with net revenue and unit. And if you divide the revenue by the unit, you're gonna have weighted average these 3 prices. So to get the full picture of what's going with the promotion, you need additional database which actually track what are the different price points available depending on the condition, together with this purchase requirement in case there are this so-called multiple price point promotions, right? And a lot of companies are doing, so you're maybe wondering why some companies are doing this in complicated way. The reason is compared to simple promotion like percentage discount or dollar discount, this kind of complex promotion actually tends to have better ROI, because you essentially have multiple price points, right? With that, you can better customize who is actually going for a certain price point. So because of that, for certain categories, this kind of complex promotion is more of the norm rather than the exception, right? So it's something you have to live with. As an example, soda categories and cereal categories tend to have must buy or BOGO promotion much more compared to percentage discount or the absolute dollar discount. So price point is actually more complex than just revenue divided by the unit. So you need to actually have more data to better capture what's going on in reality for promotion price. Another challenge I have seen, especially with the syndicate data from the the IRI Nielsen, is so-called split week problem. Also, this is happening even with the retailers if they are not careful. And this is happening because pretty common practice of the using the common definition for the weak definition for the data. So usually for past data, instead of storing the daily data because data volume, retailers or syndicate data providers store data in the weekly level. But the problem is depending on the location of the chain, even for the same retailer, their promotion week definition can be different by region chain combination, right? So usually for the database, they are using Sunday to Saturday to define 1 week. But certain location, they actually have Wednesday to Tuesday to run the promotion calendars, right? With that, if you have the proper promotion calendar with this yellow line, right? So this is actually what happened with your promotion. So in the March of 2017, the True Data actually has $2 promotion, right? And then around that, basically you can see that larger bump and then reduction in volume. But with this distortion of the common week definition across all the stores, you have to mix up the non-promotion week with the promotion week. And so with that, if you plot out the volume with the new common definition of the database, you will see that the promotion bump will be reduced. And then you can also see that the non-promo week also get flattened, right? So this will distort actual promotion effectiveness because of the weak definition. And without actually handling this properly, you're going to have a mismeasurement of the actual promotion ROI, right? And this is happening quite often. So the fix is that you can go with the daily level data and then apply proper promotion week definition. But if you are not careful and then just apply common week definition, which is seems to be pretty kosher, and there's nothing wrong with that assumptions, right? But that can actually, the mismatch between promotion calendar and database week can actually affect your overall measurement effort. This surprisingly, this problem exists for 30 years. It's not fixed yet, so I'm wondering when it'll get fixed. But this kind of shows that without actually paying good attention to the data, this kind of mismeasurement can happen without doing actually happening, right? Another key mistake people make is usually a lot of talk about size of data. We have billions of observations without thinking about the information in the data. So let me make this concrete by actually contrasting two different scenarios. So let's say that you have data from the Walmart with 4,000 stores and 1 year worth of data with 500 SKUs. So here, the number of SKUs are same, when the Best Buy with less number of stores, right? So if we are just simply counting number of data points, this Walmart example have much more, maybe 2 times or 3 times more observations, right? So you can argue that we have much more data in Walmart, so it will be easier to do promotional price modeling, right? But if you actually look at the data, since Walmart is EDLP, meaning that they do everyday low price, not much price changes without the rollbacks. So it will be essentially flat, right? So for the promotion modeling, if your price is flat, it's actually very hard to measure the impact, right? So this data, although it's sizable, it won't be useful for the modeling, right? In contrast, Best Buy data was less in terms of size, but they have more price variation because they are high-low chain, meaning they have a lot of promotions. This kind of data can be more useful for the promotion modeling, right? So the size of data is not necessarily equal to information in the data. So you need to actually think about what is the actual variation in the data you need to have to make certain technique to work, right? In this case, the price variation is key, or the number of promotion events will be key to make it useful for price modeling or promotion modeling. And one way to check is actually looking at so-called coefficient of variation. So compared to the mean, how many the standard deviation, that will give you some idea about whether you have enough variation in price in the data set to allow you to do price or promotion modeling. So check information in your data and do not equate this with the size of data is another thing need to watch out for the data. So another one kind of similar with this idea is the signal to noise ratio in the data. A lot of times, if you have a lot of data, we tend to make summary stat and focusing on the mean or average numbers around the event, right? So if you are only looking at this table on the top, so and then you are doing some before and after analysis, right? And then you only look at the average, and before event, promotion event, it was 10, and after event, it was 13. So this is actually corresponding to 30% change in terms of the revenue, right? So you would say that this is big impact, right? This is hugely success promotions, right? That's usually the conclusion people will make if you don't actually look at the data more carefully. But it depending on your signal to noise ratio or the variance, right? So you have to look beyond the mean and look at the variance to see whether this is the random noise or something impactful, even though the number itself looks not large, right? So that's something you need to check in addition to average. So as an example, if it was the case that it was less noisy data like this on the graph on the left, this 30% will be huge increase and meaningful kind of increase, right? But it's possible that your data came from the graph on the right. So a lot of noise data, and the 30% change is basically pretty much the norm, right? So with this high variance scenarios, the 30% change doesn't mean anything, right? So you have to interpret this average change in the context of your data, and then need to factor in variance or statistical significance to tell something about the change, right? That's another common mistake I've seen if you are ignoring the underlying data variance or the statistical significance. Another common kind of challenge I've seen is so-called reverse causality. This is actually happening a lot, especially with the budget setting in marketing. So a lot of times what people do is using the last year sales to allocate your advertising or promotion budget, right? Which is nothing wrong. Basically, the assumption is that the larger groups need to take larger budget, right? So with that, you can create interesting two example, right? So here I create the fake data set where the sales is the intercept with random noise, but advertising effect is actually 0. So here I know that true effect of the advertising to sales is 0, right? But based on this budgeting process, you can actually create the data that the advertising budget in period T is the sales amount in the period 1 week before times certain coefficient, right? So essentially we are using last period sales to allocate the budget, right? Here we do know that there are no true effect of advertising, but our budgeting process actually create the correlation between advertising and sales by design, right? With this, if you are plotting out sales with the advertising over time, you can see that, oh, there are really good correlation, right? And if you are doing the simple or linear regression, you'll see that there are huge impact of advertising, right? So this is sometimes happens with actual data. So you have to think about the budgeting process, how your advertising or promotion events get allocated. Without properly controlling that, you can identify some causal impact without actually having any, right? So this reverse causality needs to be carefully considered, and you have to know about how they allocate the budget to properly model the causal effect of the advertising or the promotions, right? This is quite typical in the observational data, and that's making things quite more difficult with observational data. Yeah, another example is so-called confounding. So with the A/B testing, you don't have to worry too much about confounders, because the randomization basically handles this properly, and by comparing the test and control, you can actually get the effect. But with the observational data, unless you are carefully controlling the confounders, you can actually get effect even without any true effect, just due to the difference in confounding balance across the what's treated and what's not treated, right? And this example is from the New York Times, and they are showing that all the task score based on income level is actually, you can see that it's higher with the higher income, right? So they are claiming that income is responsible for the academic achievement based on this data, but obviously this correlation, right? So it doesn't really tell the true story, right? It could be that, there can be confounders around this, maybe some family disciplines or the overall academic effort and everything else, which is kind of hidden behind, it can be a causal, but it actually shows a correlation between income and academic achievement, right? So need to be careful about missing compounders whenever you are doing the causal modeling with the observational data. So these are another kind of more practical data mistake I've seen in the context of the promotion modeling. So I will just give two examples. So one of the main thing is sometimes if data is limited, people are trying to do this causal modeling of the promotional price effect by using cross-sectional data. It's very dangerous. It's not actually feasible unless you use special technique. So it's better to actually look at the sales within the product over time to get most from the within product variation of sales based on the price, right? So don't try to use cross-sectional data to do causal modeling of the promotion. That's quite difficult. And also another one is the seasonality control. So usually to properly control seasonality, you need at least 2 to 3 years worth of data. But if you are trying to do with less data with 1 year, it's not possible to properly control seasonality. So it's important to have at least 2 to 3 years of data to enable the promotion modeling in general. And another common mistake is the instead of retail sales data, using the factory shipment data. This is happening a lot with the manufacturers because this is more available, readily available for them compared to retail sales data. But with factory shipment data, there are forward buying from the retailers, so you don't actually get true lead for the retail sales. So if you have choice, retail sales data is much better compared to factory shipment data. Okay, so I will switch the topic a little bit to modeling part. So just talk a little bit about what is the major difference between the traditional machine learning and causal machine learning. So in the traditional machine learning, it's the focus mostly about the predictions, right? And it's okay to be a black box as long as you predict well, right? Also, with that, it may predict better on average, but it sometimes can generate counterintuitive result if you use this in the simulation or what if kind of analysis, right? So one example is, I try to do random forest for the promotion modeling and using the model to simulate for the price change. And some cases, it actually resulted increase in sales when you increase your price, right? And Andy just basically complained about this because they don't believe that the sales will go up with the price increase. But with the plain vanilla application of the typical scikit-learn or TensorFlow tools in general, do not have actually that control, right? So you have to be aware about this counter to result if you are trying to use this for the simulations. Also, another thing that usually we don't consider is many of these models are highly predictive, but some models are less optimization friendly, right? In contrast, some class of models are more optimization friendly. This can be a consideration when you are trying to use the machine learning model in subsequent optimization or planning process, right? Also, the underlying data can drift, right? And traditional machine learning models do really well when the training data is similar to testing data. But if there are concept or data drift, they tend to suffer, right? Those are key characteristics of the traditional model. Nothing wrong with them. It's just you need to know about what they are good at and what is the limitation they have. In contrast, causal machine learning tends to care more about the causality. So the focus is more about the measuring the impact, the causal impact, together with allowing counterfactual simulation, what if simulation, especially with the simulator kind of application, right? Also, ideally, you wanna explain what's going on with different scenarios. So more explainable, interpretable kind of models are preferred over some black box model, which is hard to interpret, right? Also, sometimes it's required to put some constraint by design because data is not perfect. So based on the theory or some previous experience, you can actually put some parameter constraint to make sure that the overall, the model inference you make at the end is actually making intuitive sense. As an example, once you do a lot of modeling to measure price elasticity from some certain model, even after careful data handling and modeling, sometimes the estimate will be up because there are not much in the data. There's nothing you can do much about it, right? Then you can. It's actually okay to put some constraint guardrails to make the range over reasonable range. As an example, for price elasticity, we expect them to be between minus 0.5 to minus 5. So if you have positive value or too high or too low value, then you can override this with category average or subcategory average or whatever heuristic or the model based kind of way to put the constraint, right? So for that, a lot of modeling technique which can pull the data information across different location product will be helpful, because if there are not enough information in the individual product time series for the promotions, you can borrow information from other product or other store, other location to actually get more good lead, right? Also important to realize the what kind of assumption or impact you're making by choosing some model technique or modeling specification. As an example, if you are choosing log-log model with the heterogeneous coefficient, that has some implication of what you actually assume for the optimization, right? So logs of sales to log price model assume constant elasticity. So you are actually making implicit assumption that the price elasticity doesn't change by the price, right? Whether it's reasonable or not, it's actually questionable what kind of change we are talking about, but it does affect the optimization result, right? So you have to be mindful about what the impact of the modeling technique and the model specification on optimizations, right? Also, sometimes using the underlying theory can be helpful with the generalization, but as a downside, sometimes this can be constraining the result too much. So there are always good trade-off between constraining data with the theory, but also getting the maximum from the data, right? So that's the main difference between the causal ML and traditional machine learning. And in the causal ML, the focus is more about measuring the impact size from the certain treatment or certain changes you make, and also allowing that the counterfactual simulation is intuitive and then useful for future planning. Right? So with this in mind, so what other kind of high level output you can generate once you do this promotion demand model by having causal interpretation, right? So one of the thing you can do is so-called promotion DNA. So I mentioned that at the end of the day, you will get the incremental volume or incremental profit by the promotion event. So that's this kind of chart you can create. But here you can actually further break down by the drivers, right? So if you have the 100 incremental sales, you can further break this down to how much is due to the own price product promotion or price level change, and how much is due to the promotion of the other product, right? Or how much is due to the change in promotion tactics from percentage discount to BOGO or most by 4, right? And how much is due to the feature or display or other non-price promotions, and how much is due to the seasonality, right? So this kind of breakdown can be very helpful to see what's going on and why this is happening. Also, if you do this at the higher level, then comparing last year to current year, or maybe last quarter to current quarter, you can actually do due to analysis at the higher level. So we started the sales of the X dollars, and because of this bucket, the seasonality and competitor promotion and our own discount level and all, And this is actually reducing the overall sales, and this is improving the sales. So it ends up with this kind of number this year, right?
I
So
mean,
these are highly useful for business executive to understand what's going on with the promotion and what are the major drivers which have driven the effectiveness of promotions, right?
hi, Mina, we have a question from the audience.
Okay.
I have a question about the overall, like if there's a special event, like external event, how would you deal with it? For example, like we had a COVID-19 lockdown, and would you disregard those data because that's going to be have very different seasonality and this kind of factors you're showing, or would you only use those data to calculate during COVID predictions?
Yeah, that's a good question. So ideally, if you know that some major external event is happening, right, then it's better to incorporate it into the model as another control variables, right? So here, as for COVID example, that was actually something I looked at about 2 years ago. So it did impact a lot for the promotion. Essentially, people get less price sensitive, right? Also, so that means the price responsiveness will change with the COVID, and also the overall level of the product sale change a lot. The intercept or the base level of product, right? So some product like toilet paper moved up a lot, but the other categories actually went up quite a bit, right? So you have to adjust those with the external event indicators, right? So the short answer is yes, you need to control those. And if you do not control those, you're going to actually see from your data. So if you fit the model without those external event control, then your measurement of the error, prediction error, will go up for those period or those locations where you don't control those events, right? So that signals that something is going on. So you have to actually control some major events, right?
We have another question.
Okay.
I have a question about the co-founder you were talking about, just based on your research experience. What are some typical co-founder you find for modeling your promotion effectiveness? And also, once you find those co-founders, what are some techniques you use to control those for the modeling?
Yeah, those are good questions. So usually, yeah, I mean, the most important, so if you go with the order of impact, right? The most, my experience is that for the promotion for the certain product, right? Usually the own price change and own promotion change is most important first degree, right? So just give you an idea about the number. The own price elasticity usually on average about 2.4, 2.3, right? Compared to that, if you compare it, that's first order impact, you have to control those. But another one is seasonality, right? So obviously Black Friday or holiday has huge, or even the weekend have huge impact. So you probably need to control seasonality and trend. So those two are the top two I would actually start with. And some external events like the COVID or anything major will need to be controlled. On top of that, the second order group will be cross-product interactions, right? So the promotion of the other product will actually matter a lot, but the order of magnitude of this will be about 10 to 20 times smaller compared to own product effect. Usually that's order of -2, but cross-product effect is order of maybe 0.2. So it's 10 times smaller, right? But but with a lot of product with that happening, that's actually important. But the key challenge there is actually how to figuring out which product is more similar to my product and only weighting them properly, right? So it's not, so in theory, you can put price and promotion schedule or other product as a covariate, right? But that will really expand your variable too much, right? So usually that's not tractable. So in my experience, it's actually better to get some measure of product similarity from the other data and then utilize it to reduce your parameter to estimate, right? There are some techniques to do this, right? But those are second order effects you need to control. And another one is the across time kind of compounding, right? So if you have the previous promotion because of this promotion dip and post promotion dips, So you can have the time dependencies. That's another thing to control, right?
We have one more question.
Yeah, hi. Have you done stockout analysis before? And like, how did you approach it if you did so?
What was the question again? What analysis? Sorry, yeah.
Have you done stockout analysis before?
Stock out, yeah.
And yeah, then how did you approach it?
So stock out, I mean, it depending on the modeling goal, right? So usually there are two kind of main applications I've seen. One of them is actually try to predict stock out without having stock out audit or information based on the suppressed sales. So the intuition is you have some expectation of what would have been the level of sales, right? But if you have some dips in the actual sales, you can infer that that might be due to stock out, right? That's more about detecting the stock out without having good data on stock out. Another application is once you have the either with this technique or actual audit, you know the stock out. And another modeling try to do stock out lost sales estimation. So how much of the sales get lost because of stock out, right? Those two are the main ones I've seen.
Thank you.
Any other questions?
Not for the moment.
Okay, so let me go back to then this one here. Yeah, so those are the major kind of output, which is useful if you do backward-looking kind of analysis. And another key thing is simulator. I don't have the example here, but essentially you can build your app, end user app, where you have the choice of the product and location and product, and with the promotion kind of tactics and price point and feature and display support. And based on your choice, it will allow you to simulate how much volume and revenue and profit you're going to generate for the given scenarios, right? And you can even do calendaring with those apps. So that is pretty cool to build once you have this modality. So little kind of comment on the modeling approach in practice. So as I mentioned a couple of times, the key thing is the nature of data is multiple product, multiple location over time. So borrowing information from the similar product or similar market is a key because individual price series do not contain enough information for many products, right? The pooling of information is a key. Because of this, hierarchical modeling technique or mixed effect or Bayesian modeling is more preferred in practice. Another benefit of this approach is that it's quite interpretable. So that's usually the starting point. And a lot of actual commercial application of this is based on the linear or nonlinear mixed effect models, right? And based on, you don't have to be fully Bayesian. You can use the residual maximum likelihood technique to get the coefficient as long as you properly model the different hierarchy of the coefficient. So usually the intuition is that so you try to get most from the individual product and individual location, but if you don't have information for certain time series, you borrow, go up in the level and then try to borrow this from the similar product or similar location. That's the key idea. So you basically have the hierarchy of effect. So if you have information in the lower level, try to use that to estimate. If not, you go up one level and then try to use the average at the level to infer the overall impact of the promotion, right? That's the key kind of idea here. And so also there are a lot of multi-collinearity because of some of the highly collinear. So like seasonality, a lot of sales happen with the seasons, right? Or the holidays. So you have to need to carefully look at this aspect, especially when you are making causal claim. There are some gray model, but which is computational slow. In practice, this is a less preferred because of the computation time. But now there are more advanced with the complex techniques. I think there can be a room for more adoption of complex techniques, especially with the open source package tools and also now a way to speed up these computations, right? And also computation detail matter a lot when you do this in scale. So sometimes waiting for a couple of hours is not a big deal, but wait, you need to wait for a couple of days, that become a problem, or even a couple of weeks, right? So a lot of computation optimization, like sparse matrix technique and using stochastic gradient descent instead of doing full uh, uh, data in one batch, and parallelization, those kind of techniques are quite useful to go down in terms of the overall computation time to do this in scale, right? Also, in many of the academic research tends to focus on brand level model, but since the actual operational unit for the product is SKU or UPC, so in practice, the SKU level modeling is preferred compared to brand level models. Those are what I have seen comparing what's actually used in practice. And if you are doing this for first time, although seemingly simple, log model with the hierarchical coefficient, meaning the coefficient can also change based on product attribute and location, is actually a good starting point. So also this has an advantage that you are actually directly getting price elasticity, although there are fundamental assumptions that that's constant elasticity, but within the 10% kind of price change, that's reasonable assumption, and this is actually easier to communicate. So usually good kind of starting place, a simple model have proven kind of impact and also quite interpretable. So I would recommend with this kind of model, but using the plain ML model just off the shelf has some challenges. You have to actually tweak it by applying some constraint to make sure that the counterfactual simulation is become more intuitive, right? So there are some tweaks you need to make with the machine if you are using the machine learning model like random forest or XGBoost. But I think they also allow to apply monotonicity constraint for price as an example. So with those kind of tweaking and also careful selection of the causal drivers, you can actually do quite well with this approach too, right? For deep learning, I haven't seen good success yet, but I think there will be some promise with this recent advancement with the multivariate time series model motivated the transformer, but former kind of trial with LSTM or plain vanilla deep learning model wasn't so successful. One of them is essentially talking about multi-product, multi-location time series, multiple time series over time. So there are pretty big difference across product, and deep learning model basically do not generate well unless you do proper grouping, right? So that has been my experience, but that can be advanced in these three. But that's kind of sharing what worked in the past when I tried and what didn't work, at least at the time. So with this kind of modeling, also the kind of nice chart you can make is the ROI, profit ROI, and revenue lift kind of graph, right? So this basically allow the key executive or leadership or the promotion pricing team to trade off between the revenue goals and also the profit goals, right? So they can actually see which, with this quadrant, they can see which promotion event they need to do more, or which one to improve, right? Or which one to actually kill because they are not making any leaps and they are not really ROI positive, right? So this kind of summary with the promotion event can be quite useful as a dashboard, right? So that's up to the modeling. So I have small section on prescriptive analysis, which I will maybe only point out a couple of important points. But after you do the modeling, you can build a simulator or do optimization, right? But usually the companies which are doing this first are quite happy with the simulator or the predictive what if scenario tools in general, right? Once they mature in the analysis journey, and then they will ask about, okay, it's good to have a tool to actually do what if scenario analysis, but it would be better if tool actually recommend us to what to do in terms of promotion calendar or promotion plans. So that kind of naturally to question about prescriptive analysis. So that will be the most advanced kind of level. So I think usually companies go through these kind of journeys. So they tend to start with descriptive data science, where they're looking back and they try to figure out what's going on, to prediction into future, like the predictive modeling. But once they mature with the stage, the natural question about prescriptive data science, what should we do? What would be your recommendation about the promotion calendar in year 2023, as an example, or 2022? So depending on the stage, also the relevant types of the toolkit change. I think there are more demand for the optimization in general beyond the predictions, right? So, might be a good area to pick up if you don't have previous kind of background in optimization or reinforcement learning in general, right? So with that, this, you may know that there are 3 domains that data science need to know well: business domain and software engineering and statistics and machine learning. But maybe you can add one more dimension about optimization to contribute more to the prescriptive data science, right? So this is usually what previously was domain of the operation research, but I think more and more that there are no needs to link predictive modeling, statistical or machine learning model with optimization to really make a recommendation about what to do, right? So this is of one thing that I want to emphasize, that there will be more opportunity to link these two in the future. It will be multidisciplinary, but there are a lot of applications which call for collaboration between optimization and machine learning. For that, let me just briefly describe the major problem types, and also kind of using the price promotion as an example about how you can actually apply these techniques. So for the prescriptive data science, one way to think of a problem type is actually thinking about whether the dependency over time matters. So some problem is simple enough to only consider one period at a time. That's called a static kind of a problem. But some problem that by nature have dependency over time. That's called dynamic problem. So those are one dimension to classify the different types of problem, right? Also, another dimension to think about is whether you are focusing on one single agent or single player at a time. This is simpler by definition. But if you have multiple player agents, you have to consider interplay between them. So more like game theory, right? So that will be more complex. With that, you can classify this problem into 4 different types, right? But you can start with the simplest case, single agent static optimization problem, right? But it can be as complex as there are multiple players and over the lifetime. So we have to think about dynamic kind of game with multiple agents, right? So this is one way to kind of classify what kind of problem you have regarding your prescriptive data set problems, right? So this can be a little high level. You're wondering, how this can be actually applied. So let me take the price optimization as an example, right? So with the price optimization, if you are ignoring the dependency over time, like post dip, this will boil down to multi-product price optimization problem, which will be static. As long as you are ignoring the time dependency, that will be a good place to start, right? And it will be, then you can use the, assuming that you are assuming away, you are not thinking about retailer retaliation or price reaction. That can happen over the long term, but for now, let's ignore it, right? Then you can consider this a single agent static problem, right? With that, you are trying to optimize multiple price point over multiple product, right? And the technique you can use is so-called constraint optimization. And with that, to make it more practical, you need to put a lot of constraint that this optimization problem need to adhere, right? So the types of the constraint I've seen in practice is these kind of bucket. So usually making too dramatic price change is not really acceptable for retailer or manufacturer. So you have to put the bound constraint about upper and lower bound. Maybe plus minus 10% will be the only range you're gonna look at, right? So this is quite common. And also cost constraint, right? You wanna make sure that you have a profit So you have to put the cost as a low bound constraint for your price optimization. And also, you don't want to raise price too much compared to your major competitors. So you can actually put competitor price as a upper bound to be practical. This is more a heuristical approach, but tends to work pretty well in practice. And for a multi-product kind of case, there are some line pricing requirements from manufacturer if you're retailers, right? So as an example, for soda in general, the same package size tends to have same price regardless of flavors, right? So 12 ounce 12 pack or 2 liter bottle all have same price as long as the package size is same, right? That's the requirement from the manufacturer. Then you have to adhere this equality constraint across the multiple flavors within the same package size, right? Also, in perception, store brand tends to be cheaper than national brand. You have to then put some inequality constraint to make sure that national brand prices tends to be certain times higher than store brand. Also, you want to maintain the overall product hierarchy, price hierarchy. So what you consider a premium brand need to be more pricier than the regular brand, right? Also, finally, there are different package size, and usually the larger product in the package size tends to have lower per unit price, right? So you have to adhere this pack size curve. So these need to be put as a equality or inequality constraint in the optimization problem. And then you need to define your objective function, usually profit or some multi-object function for profit and mix of the profit and revenue. And you can use the constraint optimization routines to actually do price optimization. So this is the example of what practically is used as a constraint in terms of price. And with that, you once you clearly define your constraint with the object function, you can apply the key optimization technique to come up with the recommended price, right? Yeah, so this shows some taxonomy about different optimization problem for your as a starting point for you to explore further. So yeah, so if you are less familiar with the optimization, depending on these dimensions, there are different types of optimization, right? So for the constraint, we talked a little bit about what are the constraints we usually use. So there can be a constraint optimization which adhere this constraint, or there can be simpler unconstrained version. So those are two different types of optimization method. And also depending on your variable you are changing, there can be a continuous kind of optimization. So price, you can charge any price point. So that can be considered a continuous variable. Or if it's assortment, you either need to put it or out. It's really binary. So those are called discrete kind of decision variables, right? Or you can have mix of these, and that's called the mixed decision types, right? Also, objective function wise, usually much easier to single objective if you have single objective function, but sometimes you want to have multiple objective with some weighting between them, right? So that's called single objective, multi-objective kind of optimization method. Also, depending on your object function and the constraint shape, a linear problem tends to be easier to solve, but most of the cases is nonlinear problems. So there are distinction between linear problem and nonlinear problem. And finally, there are distinction between level of uncertainty about your problem. So deterministic is assuming that you can pretty much predict with good confidence, but uncertain kind of cases actually model what is the uncertainty around your prediction to incorporate the random nature of the actual event, right? So those are kind of the taxonomy that you can use to map your given business use cases to what's available in terms of your automation method, right? So this can be a good starting point. And if you are interested, there are good packages in SciPy, which is a good starting point to actually playing with some of this method with actual data, right? So let me conclude with the lessons I learned by applying this kind of technique in practice. So it's, as I mentioned, it's quite important to have a quick win and then with the pilot. So rather than do this with the entire category or entire portfolio, it's better to build credibility by doing 1 or 2 pilot categories and show the impact, and then it's natural to scale from that. So that's usually a good way to get buy-in. Also, many of these, the modeling wouldn't work if there are problems with the data. So invest heavily in the data foundation and garbage in, garbage out, right? So it's okay to start with a simple model, but you need to invest heavily for data quality and data foundation to make this really to work. So you need to take more data-centric approach. And then initially it's okay to be simple on the model, then later you can make it more sophisticated. That seems to work better than spending more time in the modeling and less time on data, right? So that's the mix we need to have, at least initially. And also it's okay to simplify. I mean, it's ideally you want to use more complicated models, sophisticated model, but as long as it's better than current practice, the impact can be made. So sometimes it's okay to ignore the second order impact or some complication and focus on 80-20 answers, right? So I know that a lot of data science have some hesitation about this, but having the practice better compared to current one is usually enough bar, right? So it's okay to simplify and make some assumptions, especially initially. And once you get the initial quick win, then you can make it more complicated, right? Also, data augmentation is quite key. So usually aggregated POS data at the store or chain level is good starting point for first win, but usually not enough to getting more sophisticated insight. So you might need to augment this with the other data set. As an example, if you just put price and promotion for all other product, it will be because of dimensionality. You have 5,000 plus variable with maybe 153 data point for each product, right? So it will be large P, small n problem, right? But if you have purchase structure estimate from the other individual consumer panel data that actually give you similarity measures, then you can actually dramatically reduce the overall parameters. And then by doing this data augmentation, you can actually make some model which is nice to understand and also feasible to estimate, right? So this combining different types of data to make something infeasible to feasible is actually key to leverage. And in my experience, it's possible to generate 2 to 4% profit impact with the good data and proper modeling. So this is a good way to actually bring the data science technique to better doing better with the pricing of promotions, right? Also, another lesson I learned is modeling is only a small part of the entire solution, maybe 5 to 15%. There are much more, like the data engineering foundation to actual app building and then actual the end user usage. So you need to build the solution to really create the value, and need to also watch out the data lifecycle and some monitoring kind of solution. Once you deploy this in production, it's actually not enough to do one-time modeling and then forget about it. So you need to have some way to monitoring the data lifecycle and also the model performance to figure out when to update the model and what to do, when there are some data drips or certain problems. So MLOps is another, good kind of topic to learn more, because that seems to be more and more important these days. Also, a lot of business guardrail can be considered as a constraint in the optimization. So you need basically some marrying of the mathematical optimization technique with the business judgment by using the constraint as a glue. So that's interesting kind of way to do this. And for this kind of technique, there are limitations about not seen in the data. So it's fine to use this model to do price adjustment up to 10 plus minus 10%. But if you extrapolate too much, it will be dangerous, right? So don't extrapolate too much from the historical price levels. Model is great, but model is simple assumption, right? So if you try to go beyond what you feel comfortable about, that can be dangerous, right? And finally, to get really buy-in for this kind of usage, especially the impact measurement and causal inference, usually interpretive model is going much adopted and they get easier to get buy-in compared to black box model. Something you need to consider if you wanna use the model to measure the impact from certain marketing event. So let me stop here. Any questions?
Thank you, Mina. I think we're about out of time, so let's have a round of applause. If you were late coming to this seminar, Michaela's at the back of the room, she can take your attendance. Otherwise, I want to thank Mina for a fascinating talk, and I want to thank everyone who attended here both in person and remotely. I hope to see you in some of our future seminars. Thank you so much.
Thank you.